Good day guys, this is your tutor engineer. We are continuing with graphs and motion in one dimension. Let's start with today's lesson. The velocity time graph of a train moving in a straight line is shown. Its initial position at time is equal to 0 seconds is taken as 0 meters. The train initially starts moving to the west. So we'll take the west as the positive direction. So the first question is determine the position of the train from the reference point 0 meters at time 20 seconds. So this is the point of interest. Let's determine the position. So let's remember that this is we're dealing with the trapezium, where this side is 20 seconds long, and then that one on top is 5 seconds long, and then the height or the distance between the two sides is 60, right? So this side here is 60 meters per second. So let's calculate the area. Remember, since we have the velocity time graph, then we require to work out the displacement. That means we have to work out the area. So the displacement is equal to is equal to h times 2. That's the formula of the trapezium. So h is 60 divided by 2, and then the a is 5, and then the b is 20, right? So remember, this is the b, that is the a. So the displacement is is 750 meters west. Okay, now let's go to Roman figure 2. This was Roman figure 1. Now let's do Roman figure 2. We need to calculate the displacement at 45 seconds. Okay, we will work out these two areas. So it's one area, in fact, it's one triangle. So let's just work out one triangle. This particular triangle has got a base of, so the base is 45 minus 20. This is 25 seconds in length, which is the base, and then the height is going to be this one. It's minus 40. So the area of a triangle is half base times height. The base is 25. The height is minus 40. So 1 divided by 2 times 25 times minus 40 is minus 500 meters. Since we're interested in the displacement at 45 seconds, we know that the displacement is cumulative. So you must add 770 minus 500, and then the displacement is going to be 250 meters. Since it's positive, it's going to be moving towards the west. Okay, so that is it for question A. Then question B, determine the acceleration of the train between 10 and 30 seconds. So the acceleration, let's come back. Okay, with the change of a pen, remember we're given the velocity time graph, we need to work out the acceleration. That means we're going to work out the slope. So time is 10, here's 10 seconds over here. That means the coordinate here is 10, and then the v coordinate is 40. Then at 30 seconds the time is 30, then the v coordinate is minus 40. So let's work out the acceleration. From there on, the acceleration is going to be the slope. So we'll say 40 minus 40 divided by 10 minus 30. So the acceleration is going to be 40 plus 40 divided by 10 minus 30 is minus 20. 40 plus 40, 80 divided by minus 20, which is going to give us minus 4 meters per square second. And you can simply say it's 4 per square second, since the direction, the positive direction is west. That means this one is going in the opposite direction towards the east. So that's the acceleration. Okay, so let's go to question C. What is the instantaneous velocity of the train at 15 seconds? So let's read it off the graph, where time is 15 seconds. That corresponds with 20, right? So this is the velocity, instantaneous velocity. So here we can simply say velocity is 20 meters per second, right? It's west, since west is the positive direction. And then the velocity at 30 seconds, here is time equals to 30 seconds. That corresponds to minus 40. So it's minus 40. Velocity is equal to minus 40 meters per second, or simply say 40 meters per second east. And then the last question is, during what time interval was the train moving east? Basically they're asking us when the train was negative. So we know that the graph is negative from 20 seconds. So this entire part of the graph is negative up until 45 seconds. So our answer here is going to say where time is 20 seconds and 45 seconds. So that is going to be the answer. So we've come to the end of our today's lesson. If you like today's lesson, please hit the like button and subscribe. Stay tuned on the next lesson. Cheers.